Okay, let's move to another speaker about Docker. He's a friendly guy from PyCharm who will gladly discuss PyCharm more with you at his booth. I've talked with him today. He has a very nice UX experience, also improve it, and you can always provide him input on PyCharm. He will be talking about Docker and jailbreaks. So please welcome Ernest Handman.
So yeah, hello, I'm Ernest. I am from Germany, I live there. I'm product marketing manager for PyCharm. That means that I do various things for PyCharm. I don't know if you've ever seen a PyCharm blog, there's stuff on there that's interesting if you want to learn how to work with certain technologies. I also like good food, so if you do know about places in Warsaw that I should go and visit, I might not know about, drop by our booth and tell me about them, because that's always a nice thing to know. Alright, so the plan for this next half hour roughly is to have a look at what is Docker, why would you want to use Docker, how to take Django and to make it work with it, and then finally how to make a production ready container. So let's get started. What's Docker? Well, some of you may have heard of Docker at some point. I think it has something to do with a whale. Well, you're almost right. It has something to do with a whale. Unfortunately, not that kind of whale. But let's keep going with the nautical theme. So back in the day, like 100 years ago, if you wanted to ship things from point A to point B, let's say bananas, for example, it was a fairly complex process because at any point in the chain, from you at your banana farm until the guy who eats the banana, everything needs to be specific for handling bananas. Like there needs to be guys who know at some port in the middle of the road how to deal with bananas. And then quite a while later, there was some innovation in the shipping industry, and they came up with containers. The cool thing about containers are that only the person at the very beginning and the very end needs to actually know how to deal with bananas. The rest of the chain just deals with containers. They handle this standardized object, which they take from a train onto a boat, from a boat onto a truck, and they don't care about what's inside. All with software, it's kind of the same thing, right? Back in the day, if you wanted to deploy, for example, a PHP application, everybody involved in the process would need to know how PHP works. Everybody would need to know how to install PHP, how to install dependencies for your application, and how to, in the end, make it work. This includes other people on your team, people who want to contribute some other way to your software. This includes people who want to deploy your software. In general, everybody would need to know specifics for the specific runtime environment. And this, of course, is different for everything else. So if you have a PHP application, it works completely different from a Python application or a Ruby application. Now, a couple of years ago, people came up with a nice solution for this. It's called a virtual machine. And virtual machines basically give you the benefits of containers in shipping to software. Now, rather than having everybody need to know how your specific application works, they just need to know how to click the play icon in VMware. You just ship them this image which already has everything configured, and they just need to know how to get it started. Then there was this nice thing called Vagrant, which allowed you to configure your virtual machine as code. So rather than starting up a Ubuntu virtual machine, which you don't installed from an ISO and then clicked and ran the command yourself in order to do it, you just have a piece of code which defines, okay, I'm going from a Ubuntu virtual machine, and then I'm provisioning it with these various commands, or using Ansible, for example, to store your configuration as code. Now, a somewhat more recent development is going from virtual machines to containers. This is, in essence, you get the same benefits, you get the same kind of experience, however, it's just a little bit faster, it's just a little bit smaller, just a little bit more efficient. Now, why is that? Well, let's have a look at the difference between a container and a virtual machine. It doesn't really work all that well with the screen here, I guess, but you can see what's going on. So, with a virtual machine, you have several abstraction layers, right? The virtual machine basically gives you this virtualized hardware that you're running on. It gives you a virtualized CPU, a virtualized memory chips, and a virtualized hard drive. And that means that this operating system, when it's booting up, it needs to explore all that and see, like, what kind of hardware do I have? Oh, it's virtual, can I work with that? Sure. And it goes through this entire process, and it's a huge pain. The cool thing about containers is that because it's not actually virtualizing at that level, it's just like some kernel trick in the Linux kernel which makes this application think as if it is running in a virtual machine. Everything is already running, so this is so much faster. Like if you're starting a virtual machine, this is best case scenario like a 1 minute thing. With Docker containers, it's under a second in essence. So it just makes your life a lot easier. You can run more things on the same hardware, you can iterate more quickly, and because it already has provisioning built in, you don't have to learn a new language. Like the Docker file already provisions your Docker containers for you. There's no need to go back and add shell scripts and add Ansible. You still can, but you don't need to. Now, what does this solve? Well, I'm sure there's two types of people in this room. People who have tried to install somebody's Python project and seen this, and dirty liars. Right? And now the cool thing about it is that you can share your project with your coworkers, but you can also share it with the world. The cool thing about a container is because it is this standardized interface, there's a lot of things out there that allow you to host it. For example, there's Amazon ECS. I'm not sure if any of you have worked with that. That's a way to schedule containers on EC2 boxes on Amazon. It's getting slightly better, they're improving it, but there's also Amazon's implementation of Kubernetes, which I guess is a little more polished, and Kubernetes tends to be the new standard at the moment. There's also Google's implementation of Kubernetes, which runs on GCP, and Azure has a similar one, but it's not going to be on the slide. It's just, you may want to look into that one as well if you're interested in running Kubernetes somewhere. But of course, if you just want to use a virtual private server, like you would, for example, back in the day for a PHP application or a Ruby application, you still can do that. You just get a virtual private server, you install Docker on it, and now you can run your containers. You can also use Heroku or similar services which allow you to run containers anywhere. Now, when you're developing an application for containers, there's a set of principles called where you're making a 12-factor app, which allow you to, where people who have a lot of experience with this said that these are the best ways of developing it, and containers really work well with those. For example, the big thing is dev prod parity, where you really want to have as closely as possible what you're developing with as what you're going to be putting in production to prevent nasty bugs from happening. For example, you sometimes see that people develop locally on SQLite, and then in production go to Postgres, and that just leads to issues down the road, because some SQL statements which work well with SQLite might not work with Postgres, and you can definitely not use certain Postgres features in SQLite, and it will just cause differences which will be hard to analyze if you're not actually developing in the same environment. With Docker, because the same image that you're building is the one that you're working with locally, and it's the one that in the end goes to your deployment platform, whether it be Kubernetes, whether it be on a VPS or wherever, it's the same, you don't run into this kind of issue. So you can basically say goodbye to the works on my machine phenomenon. The other thing is they recommend to store configuration in the environment. Storing configuration in the environment is also something that's basically inherent in Docker, as we'll see later when we set up a Docker Compose environment for our Django application. And there's more things in the 12-factor app which also work well. For example, you're exposing services through ports and more. If you're interested in 12-factor apps, just Google 12 factors and you'll get a website where they go through everything, and these are some good principles to stick to when you're developing an application for cloud development. So let's get started. Now, I do think it's in the United Nations Charter on Human Rights that if you have any example application, it must be a to-do application. Don't quote me on that. And that's what we're going to have here. But we can forget about it because this is the last screen you're going to see. But if you do want to play along at home, there will be a GitHub URL on the end where you can pull it down and play around with it yourself. But so this is a Django application. Now, if you've worked with Django before, and I don't know, has anybody ever worked with Django before? Yeah, a few, exactly. Well, if you haven't worked with Django before, it's the same with Flask or with many other frameworks. In the end, you're going to have one of these commands that you run to run it locally. For Django, this is Python manage apply run server. Now, we need to tweak this a little bit when we're going to be working in any kind of virtualized environment. We need to put a port spec behind that, bind spec. This 0.0.0 port 8000 basically means that we're going to be listening on all IP addresses on port 8000. You also need to do that if you're running run server locally in a virtual end but want to share it with your coworkers, because if you don't do that, you're only exposing it to localhost, which means that only you can see it. But if you want to see your own thing in a container running your own laptop, this container is kind of like a virtual machine, so you are not watching it from the same machine. That's why you need to expose on all IPs rather than just from localhost. But now taking this and Dockerizing is actually super simple. We're going to write a short Docker file. This Docker file looks like this. It's really just a couple of statements where every statement makes a layer in this image, and in the end you can run it. So let's look a little bit closer and see what each statement does here. So we're starting with this from Python 3.6 statement, right? What we're doing here is we're pulling down an image from Docker Hub. Docker Hub is a wonderful place. Any kind of application that is commonly used at all will have an already pre-existing image, so you don't even have to think about it. You can just say, look up there, like, is there an image that can run Python for me? And of course there is. Do you want to add some Redis to your application? Easy, you just pull down from Docker Hub, already works. Sometimes we need to configure it a little bit, but it'll have on the Docker Hub page what you need to do to configure the images you're pulling down from there. But in this case, we're pulling down Python and we're specifying version 3.6. And then the next thing we're going to do is we're going to copy a file. You can copy files from your work directory into your container very simply by putting a copy statement. And in this case, we're only copying in requirements.txt to our folder. The next thing we're going to do is, and so keep in mind that Docker, when it sees a statement like this, what it does is it takes the image at this layer, it starts it, runs this one instruction, and then snapshots it. Everything under this layer becomes read-only, which will be really important when we look into caching in a little bit. The next thing we're going to do is we're going to run pip install. Now to run pip install, this means that Docker will take the image at this layer, start it up, run this command pip install -r requirements.txt, and install all the requirements, and then snapshot our image at that point. After this, we will copy in the rest of our application. And so the reason that we're separating requirements.txt from the rest of our application is caching. Because if we were to make any change in our application right now, but not in requirements.txt, Docker will realize the next time that we're building, okay, wait, requirements.txt has not changed, so we can use our cached layer. So we don't need to do pip install because there haven't been any changes, or we can only put in your new asset or your small text change, no need to rebuild the whole thing. If you were to copy in the whole application at the beginning and then run pip install, it'll still work, but because your cache is now invalidated, because you've changed anything in this layer, it'll need to run pip install for every small change you make and you want to rebuild after. And then finally what we do is we put in a default command. The default command is just that. So you can override the default command always either in your Docker Compose file or on the command line. No worries about that. But if you run the container without any command, this is what will run. And now, so what we're doing here is like a two-step process. First, we're going to go from our sources to having an image using Docker build on the command line. And then if you want to run anything, you use Docker run to start up a container. This is analogous to how you would run, for example, Java or C#. You just have one step where you go from your sources to a build artifact, and then you can run it as many times as you like. But, okay, at this point we're done. We have a Django application, and it would start up. There's just one problem. We want to have our to-do somewhere, right? And, well, we can keep them in memory, I guess, but it's not very good to have an application without a database. So what we kind of really want to do is we want to have both our application and a database server. Now, I mentioned earlier, there's this cool place called Docker Hub, which has all kinds of useful images already pre-built. So we're going to pull down a Postgres image, and then we're going to expose it like this. Internally, they'll communicate over port 5432, and then the application will be exposed over port 8000, and I'll later tell you that this we can actually omit. But by exposing this port as well, we'll be able to manage our database from like command line tools or PyCharm later on. So Docker Compose allows you to make a structure like this, and again, it's very simple. You just write a small YAML file, and like anything these days in DevOps, everything's configured with YAML, but it's nice and short. We're just saying that we're going to have two services, two containers, and the first one is the web container, and there's this instruction build dot. The dot here is just basically Unix for build the current directory. And then we're publishing port 8000. This basically means that port 8000 in the container will be published to port 8000 externally. So after you do this, you'll be able to run, you'll be able to see your application running. Then we're putting in a volume. You could omit this. If you omit this, then if we make any change, you would need to rebuild the container. That's possible, but by putting a volume in, what this means that we're bouncing our current work directory in the container. By mounting it, that means that any change that happens, either from within the container or from within our computer, will be reflected in the other place immediately. So it's also a good way if you're, for example, building something in a container, use a volume to get like what's being built out again. But in this case, we're just doing this so if we make any code changes, and like if we're running Django with a development server, anytime you make a change, it'll be immediately reflected in the application. By having the volume there, you don't need to rebuild, you can just make a change and you'll see it right away, just like you would if you're running locally in a virtual env.
Shouldn't you add the volume also to the database? Because right now the data will be stored inside the container, yes?
Yeah, so your question is, shouldn't we also volume for our database? And generally, yes. If you're running this on Mac OS or on Linux, I would recommend doing that, but I'm running on Windows for various reasons. I know, boo, Windows. And unfortunately, the volume handling won't let Postgres start anymore, but generally you're right. And now what this means is that anytime that I destroy all my containers and restart them, I'll lose all my data. For the local development, I don't think that's a huge issue, but it does definitely make your life easier if you volume this in. If you want to get instructions on that, just check the documentation for the Postgres image on Docker Hub, and I'll tell you how to do it. It's just if you're using Docker machine on Windows, it will break down, and that's why I don't. Then finally, we're linking it. The link here is actually, I think they've changed that in the syntax, and I'm supposed to say depends on, but I like the link syntax. It's quite obvious that what we're doing here. And then finally, we're configuring the database. The database we're pulling down from Docker Hub. Then we're exposing the port and configuring it with the environment. How you can configure it with the environment depends on the specific image, and again, in the documentation on Docker Hub, you'll see it there. And so these ports here, you don't need to do that. If you leave this out, the web application will still work. You can still access the database from the web container, but you will not be able to access it from your local machine. So PSQL won't work, DataGrip won't work, and by putting this in here, it will work. Now, after this configuration, which is basically writing two small files,
The links of now is deprecated. I think that recommended way at the moment is using Docker Newport, but not using links.
yes, links is deprecated, and so I'm using the default network here, so there's no need to define a specific network. I think technically links as I'm using it here is replaced by depends on, which basically means that it will always start the database before it will start the web application. Either way, after this bit of configuration, all we need to do is run one simple command, docker compose up and then --build to instruct it to build it even if it's already built. And then we'll see the output from Docker. And the text is a little small here, but what we'll see in a second is that it goes through all of these layers, as I described earlier, to create our image. And then after the image is created, you'll see that it starts these containers based on these images, and it'll give us the standard out of both containers interleaved. Is it? Oh yeah, it's just on my preview not showing the thing. So you can see here that with the blue prefix, that's output from the database container, with the yellow prefix, that's output from the web container. So even if you have like 10 containers running and your request goes from one container to the next container to the next container in a microservice kind of fashion, by having everything locked to standard out, you can easily see what's going on in the Docker Compose output. Now, if you want to work with this in PyCharm, it's also nice and easy. You can actually go to your project interpreter, and rather than having this running in a virtual env, you can go to Docker Compose and pick the container that your application runs in. And after you do this, you'll be able to run a debug in PyCharm as you do locally. All right, now let's see how we can go from this, which has all been in development still, because we're still using the development server, to production. As I mentioned, we're using the development server here. And if you go to the Django documentation, I'm sure that you'll see a very scary warning, very big in red, do not ever, ever, ever use this in production. So we're going to need to switch to another server. Now, what is another server here? There's actually a couple of options. The most commonly used options are GUnicorn, uWhiskey, and ModWhiskey, I think. ModWhiskey being not as popular nowadays, but if you're using Apache, it's still the easiest way to go. I'll continue here with GUnicorn. There's not really any specific reason for it. If you're interested in upgrading, in making your Django's application production ready, I'd recommend just looking into both of these and seeing which one works better for your use case. The common wisdom is that uWSGI is a little bit faster but harder to configure, and Unicorn has easier configuration because the configuration is actually happening in Python. All right. That switch is very simple though. It sounds complex, adding an application server and now running it that way. Well, practically it's two statements. You first pip install Unicorn, and then rather than starting with manage apply run server, you run Unicorn, which is in your virtual env, and bind it to the port spec that we put here, and then giving it to WSGI object in our Django application. If you stop out a Django application with the manage apply create application or with the PyCharm scaffolding, this file is automatically created, and you just refer to like your project name .wsgi, WSGI, not whiskey like the drink from Ireland, but that's just how people pronounce it. In Docker, this looks like this. It's a real small change. We have to add Unicorn to our requirements of text, and then we swap out this last command with the Unicorn command instead. Now there's one small issue. If we run it now, our application will work, and we'll see how things, how everything gets served through Unicorn rather than through the development server. But Unicorn does not serve static files by default. You could solve this, of course there's always multiple ways to solve it. And the simplest way to solve it is with a plugin for Unicorn. Could be called white noise, I'm not 100% sure, but if you Google Unicorn static files, you'll find it right away. That is one way of resolving it. The other way is putting a web server in front of it, and then reverse proxying our Unicorn application server behind it, which we'll do now. Again, I'm picking Nginx here. You could, of course, pick Apache or any other server, but Nginx tends to be a common choice at the moment. And in the end, our structure should look roughly like this, right? We need to have an Nginx web server at the front, then our application, and then behind that there's a database. One way of solving it is actually this approach, where you use your Nginx and then your Django in separate containers, and then just use a volume to combine the var www static folder to get all the static files into the Nginx container. But I'm going to not do this. I'm going to put Nginx on the same container. I'm gonna do that because if you put it on separate containers, and I originally prepared this talk to deploy an Amazon ECS and to do that, because ECS at that point didn't offer service discovery built in, and now they kind of do, but not really. But you would need a layer of load balancing between your Nginx units and your Django units, and that's just a lot of added complication. And by putting it on the same container, we can use a Unix socket to connect the two together, which means that we won't have the overhead of actually going out to the network for the reverse proxy. However, if your load is very uneven, you definitely do want to separate them, and also it's a little more according to the Docker way of doing things to put them in separate containers by keeping the one process per container model. But for now, we're going to keep it like this. Now, how do we do that? Well, first of all, we're going to need to pin our Python container. Because under the Python name on Docker Hub, you can get both Debian Jessie based images and Alpine based images. Even though the default is Debian Jessie, we kind of want to pin that here because we're going to actually do things that depend on Debian rather than on Alpine. So now the next statement that we have here is going to be an apt-get statement to install Nginx. Now, why would I have this huge statement here rather than just apt-get install Nginx? Any theories? Because of caching. There you go. So let's start at the end of this statement. Because, as I mentioned earlier, it goes layer by layer and the layers become read-only. If we were to run various apt-get installs and then in the end remove these caches with this rm command at the very end there, our image wouldn't get smaller because the previous layers become read-only. So even though we do remove it in a later layer, that basically is like first instructing it to add things to your image and then instructing it to make it invisible, but it's still there. If we put it in the same instruction, however, this is all run in one go and the snapshot's only made afterwards, so we don't include these caches anywhere. And because this is best practice, we need to actually start by regenerating these caches because the layer before us already did this. So first we need to run apt-get update to create the caches, then we run our install, and then we clean up after ourselves, all in one layer. Then we need to, okay, so that's that. Then further we also need to configure Nginx. which we do by putting in an Nginx config file and running the collect static function in Django to prepare the whole image to be ready for deployment. And finally, of course, we need to start both Nginx and Unicorn now within the same container. You do that just by running Nginx, which immediately returns as it forks, and then you can start Unicorn. Nginx.config should look roughly like this. The actual file is quite a bit bigger, but the important bits are here. You define an upstream, which is essentially the application server that we're going to reverse proxy. And then we say that for anything in static, we're going to get these files straight from our own file system, and anything which is anything else will be passed to the proxy, through the proxy to application server. And as you can see here, we're using this socket file rather than going out to the network. We also need to configure Django a little bit further. We need to actually take our configuration from the environment for the database and various other things. Like the secret key is also one of those things that you really want to change if you're running in production. And now the thing that I'm doing here is I'm taking all these from the environment in a way where you get a key error if it's not defined. Because what you want is for your application to fail fast, right? You'd rather that your application fails to launch rather than starts with incorrect settings for your database and then gives you strange errors rather than just saying like you forgot to configure this. But can anybody tell me what will now happen with my application when I try to build it? So we're running collect static at some point in the build process. If we're running collect static and we don't have these environment variables defined, collect static will now say fail because it gets you the key error in settings apply and nothing will happen. So let's define a small helper function. Well, small, it's pretty easy. What you do in this helper function is to try to detect whether or not we're running with collect static. If we are, then we don't raise an error. And you could of course put other management commands here later if you have other commands that you want to run during the build process. And otherwise it will raise a key error and prevent your container from starting. That would be a different solution, yeah. He asked if you could run with a different settings file. Those both have pros and cons. With a different settings file, you may include things that, well, you could have an override settings file, I guess. That would be an easy way of handling. But still, your secret key, for example, needs to be defined. Django will not start without a secret key. And in that case, you would need to have a placeholder secret key at some point, because otherwise, it would still prevent collect static from launching. So there's pros and cons to every approach, really. Now you could optimize further here, but I'm not going to show that because it's a little complex already, but you could make it more complex. One thing that's recommendable is running as a non-root user. Doing that means putting in a user statement at some point to change the user. Well, actually first adding the user, then putting in a user statement to change the user, and also various statements to make sure that various files are owned by the correct user. And you can reduce the image size quite a bit. Right now we're basing on this Python image, which is fairly big. It's like 600 megabytes. And the total, like when I created this presentation first, it could have slightly changed by now, but my image became 750 megabytes. By changing from the Python-based image to a Ubuntu-based image and then running apt-get install Python 3, that goes down to 230 megabytes. If you go down to Alpine, that goes down even further, but then you have to use their packaging rather than Ubuntu's packaging. There's ways to optimize further, of course. So, what have we done? We have used Docker to package our entire development environment and make it easy to share with our colleagues. Then, which makes it easy to share. If you use Compose, you can easily attach backing services, and if you have these containers ready, you can just push it up and run it in ECS, run in Kubernetes, and all of these various things that make it easy to run things in production. And of course, it's also easy to run things in PyCharm if you want to work with that. So if you want to play along with this yourself now, which is the best way of learning these things, you can grab the code that I was using from github.com/myname. I know it's difficult in Dutch, but it's on the program, so you can find it there, /Django Docker, nice unimaginative name, and then find the Python PL branch, which holds the version of the code with everything that I showed you today. Do you have any questions?
What about more complex applications, such as those who use Celery and needs workers running? Do you run these workers in the same container, in other containers? how do you deal with that?
Thank you for that question. The question is, if you have a celery worker, do you run those in the same container or in different containers? Actually, if you go to that repo that I just mentioned, the Django Docker repo, there's also a celery branch that has 5 containers, where you have the web container, the database container, a RabbitMQ container, and then a celery worker, which actually sends emails. So there's also a 5th container which holds like a SMTP fake server, which shows you the emails that are being sent in development. So if you want to check that out, you can see that there. But generally, the working principle is that you should try to have one process per container. So if you have celery workers, put them in a different container. And also, because these do use, like your load expectation is different from these than from your web server, right? You expect them to not have the same level of load, so you want them in different scaling groups. Does that answer your question completely? Thank you. Any other questions? There? The last Docker file? I don't know about. Oh, here. Yeah.
Yes, in here you have a mistake because you run collect static before you add your source to the container. First you run collect static, and next you copy the source.
You're absolutely right about that.
You always run collect static before you run after you copy your source.
You're absolutely right. I'm actually wondering if it's like that in my Docker file now, because I guess when I run it through Compose, it volumes it in, so that still works. But I...
Don't you think that you break the principle about put one services to one container? You put Nginx and Nginx to one container and you lose scaling.
So the question, so first a remark about like me. Sorry?
This is the second part. You lose scalable because you put 2 services to one container. You put Nginx and Nginx to one services to one container.
So your statement is I lose scalability because I put 2 services in one container. I'm going to say that it's not very idiomatic to put 2 services in one container. Like it's generally recommended to have 1 process per container. But I'm going to disagree with you saying that I have no scalability. So when I originally designed it, it was intended as an example for Amazon ECS, where these containers should be behind an elastic load balancer. So the elastic load balancer can divide the requests between these containers, and the fact that Nginx runs locally in a container does not change anything about scalability, because we can still have 20 of these containers. I'm not sure how would I lose scalability by combining these.
Maybe divide Nginx and Nginx to different containers, give you a more flexibility.
So I actually went through that about the different approaches. There, you can definitely separate Nginx to a different container, and the point that this really starts to make sense is you expect different loads. If you want to have different amounts of Nginx containers from application containers. However, in the case of this specific application where we have a fairly small amount of static things and I would expect the load to be fairly similar, I don't think there will be any scalability concerns with this approach. However, if you are Instagram, if you have an application where the static part is huge and you expect a lot of static load, then you're definitely right that it makes sense to separate these out and have Nginx containers specifically for hosting certain content and have application containers for hosting other content. However, in that case, you still kind of have this issue where any application container, well, I guess if you do it at the elastic load balancing level, so at the load balancer where you actually get your traffic, then you'd be able to also directly go from there to Unicorn rather than going through Nginx at that point.
So you mentioned with using Amazon ECS and application like Elasticsearch that kind of works, but not quite. So what's this? You said that balancing between containers.
So the question is, what would not work with ECS? So this would actually work with ECS. I've run this on ECS. Yeah, so the issue is if you separate them out on ECS, you mean. So ECS had an interesting fluke where so with ECS the way it works is you get your containers and it schedules them for you on EC2 instances that they manage. That means that whenever you start an application up, it'll be put on an EC2 instance. The issue that I was running into is that because this is a toy example, I only had one EC2 instance. And their load balancer was completely incapable of routing requests back to the same instance. So even though I had an elastic load balancer sitting between my Nginx and my Unicorn, it could not find itself. With 2 boxes, this was fine, but so that means that she needs completely separate fleets of EC2 instances, so it never gets routed back to the same instance.
So you need to separate, running separate instances because the master cannot route the multiple containers in the same host. Is that the thing?
The question is, can the load balancer never return to the same instance? And that is almost. It cannot return. Yeah, no, you're right. It can never return a request to the same instance. So if you're, oh, oops, I guess that's a screensaver. So what you're seeing with ECS is that if you have any request going from this EC2 instance that needs to go back to a service running on the same EC2 instance, it just does not complete it. It gets lost on a network somewhere. That means that if, for example, with the celery queue, it would work fine, as long as your RabbitMQ queue is somewhere else, because then they both connect to this RabbitMQ queue, which is somewhere else. But if the RabbitMQ queue and a celery worker are on the same box, it will not be able to connect to this RabbitMQ queue because it will not be able to find it. It gets lost through load balancing, which was a concern for me why I put it together. Does that fully answer your question? Thank you. Any further questions?
Yeah, I would like to ask about the data persistence, because I was considering using Docker as a way of running Django applications, but because the persistence of data in the database is I think Docker isn't meant to be running services such as databases, and we finally decided to just use Ansible roles to deploy Postgres, and as a result for applications, because to have everything configured the same way. But did Docker get any better in dealing with persistence of data?
So to summarize your question is, how does Docker handle data persistence in production? Generally, Docker's approach for handling data persistence is with volumes. Specifically with Amazon ECS, the issue you get there is that if you have a volume that is on your local EC2 instance, you don't know where it's going to be. However, there are different drivers for volumes. So I think on Amazon now there's an EBS driver for volume, so you can have a piece of elastic block storage which you volume into a Docker container. Or, but ideally you just store things on S3, for example, or on a similar service on the cloud hosting platform that you're on. Generally, and so your question, is Docker the best platform to host a database? I think, I would personally not do that. I would personally use the database in Docker for local development and then go to RDS in deployment, where I use the same version of Postgres.
We are not using cloud solutions, so we have bare metal servers and some virtualization solutions. So things related to Amazon cloud doesn't relate to ours. So.
Okay. Thank you. I think there was a question in the back somewhere.
Yeah, I wanted to ask about, do you have any experience using ECS Fargate? Can you share some do's and don'ts connecting this?
The question is to have experience with ECS Fargate. Let me explain for the rest of the room what ECS Fargate is. So classic ECS is where ECS spins up EC2 instances in your own account, and you can see the EC2 instances, you can SSH into them. With Fargate, this becomes managed. With Fargate, rather than having your containers running on instances that you can see yourself, they're running on instances that Amazon manages for you. Unfortunately, I have not played around with this myself, so I can't give you any do's and don'ts for those. Sorry. Do you have any further questions? Well, thank you guys so much for coming to my talk. I hope that you've learned something today and that it was useful. If you want to discuss things about this, things about PyCharm, I will be at the JetBrains booth in the hall, in 2 halls over. So please do drop by, and I wish you all a great conference.